Okay, so today we're going to look at section 8.4, day 1. We'll do this again tomorrow. This section, I mean, but some different stuff. We're going to talk about multiplying rational expressions. Page 573. So before we talk about multiplying rational expressions, let's refresh your memory on how multiplying fractions works in general. So if I have something like 2/3 times 5/9, how do we multiply fractions? Straight across. Top times top, bottom times bottom. And then you have to look and see if anything reduces. Does anything reduce? No. What if you add 2/3 times 9/5? Well, again, you would multiply straight across, and you would get 18 over 15. Can we reduce this one? Yes. What goes into both? So when you divide by 3 on the top and the bottom, you end up with 6/5. The other way to do this problem is we can do what? Cross cancel. Not cross multiply, cross cancel. What cross cancels? Right, the 3 on the bottom and the 9 on the top. As long as you're canceling something on the bottom with something on the top with multiplication, you're allowed to do it. Because the fraction bar really means what? Divided by, right? And so multiplication and division can cancel each other out because they are inverses of one another. So as long as it's something on the top with something on the bottom, you can do it. 3 goes into 3 once, 3 goes into 9 3 times. Now when I multiply across, notice we get 6 over 5. Same answer. Why is it the same answer? Because we did the same thing. We canceled a 3 out. The only difference is whether we canceled it out in the beginning or whether we canceled it out at the end. But we're doing the same work. Okay, does that make sense to everybody? So you can do it either way. It's up to you. As long as it's something on the top, canceling something on the bottom. Okay, what we're going to look at now is we're going to look at multiplying rational expressions. We're going to talk about, actually let's talk about simplifying first. Let's simplify this. And then we'll talk about multiplying. Now, it's very, very important, and I'm going to say this over and over, and some of you are just not going to hear it, which is unfortunate, because you already know you're not allowed to do it, but some of you insist on doing it all the time anyway. What are a bunch of you going to do? Cancel out the x squareds. Are you allowed to do that? No. The question is, why aren't we allowed to do that? Well, the answer is this, guys. This x squared on the top is part of a subtraction problem, right? Right? It's x squared minus 2x minus 15. It's part of what is essentially a subtraction problem. What does the fraction bar mean? Division. Are subtraction and division inverses or opposites? No, they are not. So do they cancel each other out? No. So you cannot cancel subtraction or addition, for that matter, across a fraction bar, a division bar. You can only cancel what across a division bar? Multiplication. Which means we have to make the top and the bottom into multiplication problems. Which means we need to factor the top and the bottom. You are only allowed to cancel factors. Factors are things that are being multiplied, because multiplication cancels out division. Adding and subtracting don't do it. Okay? It's very, very important. So, what does the top factor into? X minus 5, x plus 3. Don't forget to check it. Oops, sorry. That's x squared. Minus 5x plus 3x is minus 2x. There's our minus 15. What does the denominator factor into? Difference of squares, right? Don't forget to check it. X squared minus 3x plus 3x is 0x, so there's no middle term. Minus 9. It works. What was the purpose of doing this? Well, do you guys see that even though we still have some subtracting and adding, do you see that the top is now essentially a multiplication problem? It's some number times some other number. It's a multiplication problem now. As long as I don't start canceling stuff that's being added or subtracted, I'm allowed to do that, as long as I'm only canceling things that are being multiplied. Does that make sense to everybody? You can only cancel things that are being multiplied across a division bar. Okay, the bottom, do you guys see is a multiplication problem? It's some number times some number. Even though there's adding and subtracting inside, as long as I don't try and cancel those things separately, I'm canceling things, the parentheses, that are being multiplied. So we're only allowed to cancel factors. What cancels out then? X plus 3 and x plus 3, which leaves us with x minus 5 over x minus 3. Is everybody with me so far? Now we can cancel out the two x's, right? No, because again, the x on top is part of a subtraction problem. The x on the bottom is part of a subtraction problem. Those are not opposites or inverses of division. So the thing is, guys, that this is still all one piece. If we're going to think of this in terms of factors, this is all one piece. You have to either cancel the whole factor or none of it. In this case, we can't cancel any of it. So this is as far as we can go. Now, would you have to actually write these parentheses in the final answer on this particular one? No, because there's only one set on the top and one set on the bottom. But on other ones, you will need the parentheses still if there's more stuff going on. That's it, guys. That's all there is to simplifying these. Factor and cancel things that are factors. Whole factors, not parts of factors. Questions about that? So that's how you're going to do these simplifying problems. All right. The next thing that we're going to take a look at is we're going to take a look at actually multiplying and simplifying. So let's take a look at something that looks like this. 8x cubed y over 2xy squared times 7x to the fourth y cubed over 4y. Now there's two ways to do this. First of all, we have two fractions being multiplied. We can just multiply straight across. So when you multiply straight across, put the numbers together first. What's 8 times 7? What's x cubed times x to the fourth? What's y times y cubed? Good. Over 2 times 4? X, and then no more x's. It's just x. What's y squared times y? So now that we have it all together into one fraction, now we can start simplifying. 56 and 8, what goes into both? 8. 1 time and 7 times. So we're going to get a 7 on the top and a 1 on the bottom. How about the x's? How many x's cancel out? 1. 1 on the bottom cancels out 1 on the top, leaving us how many left over? How many y's cancel out? All 3 on the bottom cancel 3 on the top, leaving us how many? Which is just 7x to the 6th y. Everybody see that? Now, why were we allowed to start canceling that stuff out? Look, guys, any pluses or minuses in here? It's all multiplying, right? And multiplication cancels out division. We're going to talk about that now. So I said there are two ways to do this, though. The other way to do it is to go back to the original, and we can actually cross-cancel. Again, notice that everything is being multiplied. That means that this thing is already factored. So what can cancel here? Well, cancel one thing at a time. 4. So the 4 cancels the 8 and leaves us a 2 and a 1. Remember, when things cancel out completely, guys, they leave 1s behind, not zeros. Be very careful with that. What else cancels? Okay, the 2's cancel and leave you 1 and 1. Good. What else? So this y cancels that y and leaves us 1 and 1. What else? So y squared cancels out completely. with the y cubed and leaves us y to the first. What else? So x cancels out completely with x to the fourth, leaving us x cubed. And so what do we, anything else cancel? So now what I recommend doing, guys, is you need to circle the stuff that's left. Otherwise, you're going to lose track of it. What's 1 times x cubed times 7 times x cubed? And then we have a y to the first over 1, which is just 7x to the 6th y. Questions about that? Now, my personal preference, guys, on these kind of problems, it might be cleaner and easier to do it the first way. Just because this gets to be a mess when you're crossing stuff out everywhere. Okay, so be careful with that. But it will work. Questions about that one? So that's how multiplication works. Now, that was great because it was already factored. But now let's deal with one that's not already factored. 3x minus 3x squared. Over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. Now, am I allowed to cancel this 3x with that 3x? No, because this one is part of a subtraction problem. What am I going to have to do before I can even think about canceling anything? Factor. Remember what I told you guys, you can't do anything the rest of this chapter without factoring. This is why. So what can I factor out of the top of the left one? 3x. What does that leave us as leftovers? What is it? Some of you said it, but others of you were saying the wrong thing. X minus 1. So what's 3x times x? Is that what we had was a 3x squared? We had a negative 3x squared. That's not the same thing. So that's why you have to FOIL or distribute things back out to check your factoring. What should be on the inside? 1 minus x. Don't start flipping things around, guys. You can flip subtraction problems around, but you have to do something in order to allow you to do that, which we'll see in a minute. So 3x times 1 is 3x. 3x times negative x is minus 3x squared. Now it gets us back to where we started. So now it's factored correctly. What about the denominator? What does it become?
X plus 5, that's minus 1.
Good. Let's check it. That's x squared. Plus 5x minus 1x is plus 4x minus 5. It works. FOIL it out and check it. Times, what does the top factor into over here? Good. That's x squared. Plus 5x minus 4x is plus 1x minus 20. It works. The bottom, do you guys see the bottom is already factored? It's already a multiplication problem. It's 3 times x. There was no adding or subtracting, so there's nothing more to factor there. Now, can we start canceling stuff? What can we cancel first? Yeah, now be careful, guys. Really, the 3 cancels the 3, and then the x cancels the x, right? Leaving us 1 and 1. What else can we cancel? X plus 5 and x plus 5, leaving us 1 and 1. Do you notice on the top what we now have is 1 minus x times x minus 4? And on the bottom we have x minus 1 times a bunch of 1s. Is everyone with me up to this point? Now, we would love to be able to cancel some more. What two things almost cancel? X minus 1, 1 minus x. If those were pluses, could we cancel them? Yeah, because 1 plus 5 and 5 plus 1 are the same thing. But is 1 minus 5 and 5 minus 1 the same answer? No. What is 5 minus 1? What's 1 minus 5? Do you see how they give us the same number? The only difference is the positive and negative. They're opposites. So here's the idea, guys. If you want to take a subtraction problem and reverse it, flip it around, what you do is you can't multiply it by anything, because whatever you do to the top, you have to do to the bottom. So if it flips the top, it'll flip the bottom. But what you can do is you can take 1 minus x and you can factor out negative 1. So if I factor a negative 1 out, what does that leave me? Well, negative 1 plus x, right? Negative 1 times negative 1 is positive 1. Negative 1 times positive x is negative x. Do you see it? But how can I now rewrite this thing? Negative 1 plus x is really x minus 1. It flips our subtraction problem around. So what's going to happen here is we're now going to do that very method. We're going to flip a subtraction problem around by factoring a negative 1 out. So that's negative 1 times x minus 1 times x minus 4 over x minus 1, which now does what for us? And so your answer is negative 1 times x minus 4, or what should we probably do with this thing? Distribute it. There's your answer. So does everybody see that little negative 1 trick? If you want to flip a subtraction problem around, reverse it. You cannot just reverse it. You have to factor out a negative 1, and that will reverse it for you. No, you need to have the most simplified one. Yeah, if you stop here, it's not wrong, but it's not done, so you lose points. This is the one that we want. Questions about how that works? Okay, so that's how we multiply with these things. What about something like this? What do you think we should do first on this problem? Before we factor, there's something we should actually do first. Yeah, put this over 1. We want it to be a fraction divided by or times a fraction, just to keep the tops and the bottoms straight. Now we're going to factor it. Okay, so the top, does this factor at all? No, so put it in parentheses because it's all considered one piece. What does the bottom factor into? What kind of shape is that? Difference of cubes. This is really x to the third minus 3 to the third, so it factors into what? X minus 3. What is it? No. There you go. A minus b times a squared plus ab plus b squared. You've got to know those patterns, guys. If you don't know them, you've got to go back to chapter 5 and learn them, or it's going to haunt you big time. Math analysis next year, you will throw away minimum of 100 points on quizzes and tests if you don't know sum and difference of cubes. It's that simple. Don't make that mistake. That's a lot of points to give up. Okay. Does any of this stuff factor more? No. Times so what can I do now? Do what? We can try and factor. This problem is it won't factor. Cancel them out. Which gives us x plus 2 on the top, and it gives us x minus 3 on the bottom, so I would just write the answer as x minus 2 over x plus 3. Okay, questions about that? So there's where difference of cubes comes in. Okay, that's really all there is to it. So we're only going to do the multiplication ones today. We're not going to do the division ones. We'll do the division ones tomorrow. I'm sorry, it's x plus 2. Thank you. I'm sorry, guys. I just reversed those two. Just making sure you guys are paying attention. No, I just reversed the signs on the top and bottom. That's all. That was accidental. Thank you for catching that. Okay, questions? Okay, the homework then.